Hi again. You've been hopefully successful getting MATLAB on your computers, and now it's time to start playing with it. Hopefully you've even done a little bit of that, but there's a couple of specific exercises and tips I want to give you today that will get you started if you haven't already. So this is a good video to watch before you watch the one on programming in MATLAB. So this is a little more of the basic MATLAB functionality to get you really started. And so, and some of this, will be handy in the homeworks that you'll have to do in the coming weeks. And you'll see shortly, we'll do some of these things interactively on the computer. But you could ask yourself, like, why do I have this MATLAB thing? Yeah, I typed some commands, I was able to do some calculations, but my phone will do that for me. Well, MATLAB has, of course, a lot more capabilities, and we'll be seeing a number of them during this semester. But one simple and very common one of the first ones we want to teach you about, is how to make a plot. How to not with Excel, but how to use MATLAB to make a plot. And there's lots of reasons why MATLAB is more powerful than Excel. The fact that I can run it automatically through lots of data and produce lots of plots as a sequence already. It has incredible variety of control features. So it really allows you to make good looking plots that you can then export, put in reports, put in slides, whatever you're doing. So we're going to take a simple example. So there's a curve here you see in front of you. It turns out it's some vague approximation of a pressure curve, aortic pressure. So it's the pressure in the aorta, which obviously the vessel that leaves the heart. And our goal is to make a plot. So on the y-axis we have pressure, and there are units there of millimeters of mercury. On the x-axis we have time in seconds, going from 0 to 0.8 seconds, or 800 milliseconds, right? You should be comfortable with that unit. So how do we get that sort of data into MATLAB? Well, if we had a device connected to our computer, we might be able to read it indirectly, but we don't. And lots of times we don't. So let's think about how we get that in. We could get it as a file. Somebody could save the data from the device on a file, on a chip, or a USB stick. We put that into our computer and read it in, and that's certainly nice. But we're going to do it even a simpler way, more basic way, which in a pinch always works. And that is we can just take samples ourselves from that graph and estimate what the values are and just plug those numbers directly into MATLAB. And that's what I want to show you how to do. So the goal of the project will be to take this curve, to sample it at these points you see here from 1 to 9, and write them down as a table. You can see on the left side we have this data in that we can write as just a number of values, 0, 85, 0.1, 80. Those are just the first two values in a sequence of those 9 values you see in the plot, which is a very coarse approximation. You could take much better sampling than that, but this will get us started. And then on the MATLAB side, as you'll see in a second, you can type those into MATLAB. You can literally, in the command window, type those commands, load up a vector, and have those then stored in the computer. And again, we'll show you how to do that. We enter them with a certain syntax. You'll see that again briefly. And then once we have them in place, then we can conduct these plot commands. And there are some simple plot commands that will do nothing fancy, and then there are a number of modifications of that plot command. We can plot just the pressure values. We can plot the pressure values against the time. We can load the time values in on the x-axis and plot those together to get a plot that really has pressure and time as it was in the original. We can add labels to mark those axes and see a pretty reasonable result. So that's the main purpose of what we're going to do today. And then at the very end, I'll also spend some time explaining how the help features in MATLAB work. They're incredibly handy. It's always nice to know where to look for help. And MATLAB really has done a fantastic job of creating a very extensive but easy to navigate help system. And I'll show you that in a sec too. So let's go to the computer. So once you've launched MATLAB, you should see a picture that looks something like this. It'll be different depending on your operating system, but the commands will all be the same. This layout will be pretty similar, and we'll still have the same interface. As you've already seen, there's a command window. That's a very important piece where we're going to do a lot of our entering of commands, and then we'll see what some of the other windows are good for once we get going. So in the previous slide, we digitized, so we sampled at specific points, that function, that curve, and now we want to get that data into MATLAB. So how do we do that? So we go to the command window, and we're going to call this a vector, in this case p, and we're going to set it equal to a string of numbers, and we're just going to type in those numbers that we read off of that graph, and we'll put a space between each one, and you'll notice that we also put a square bracket at the beginning of all those, and I know there are 1, 2, 3, 4, 5, 6, 7, 8, 9 values, so I think I got them all here. And then I'll hit return, and then I get confirmation that I've loaded those values up. Now I also want a time base, because that signal went from 0 to 0.8 seconds, so I want to create a time base, call it t, and in that time base I want to put all those same values that we read off the x-axis. They're pretty simple. In fact, there are ways, because they're regularly spaced like this, there are ways we could automate the creation of this string, but let's do it this way. But at the end of this line, we're going to hit semicolon and see what happens. And in that case, we don't get the variable sent back to us, but we can always check. We can always type t, and it will tell us the contents of t. And if we look down here in the corner in our workspace, we have two variables defined, the uppercase p and the lowercase t, and it even tells us the values that are in them, so we can see the contents of them. So for small matrices, small vectors, this works pretty well to check what's going on, to make sure that we've got the variables that we think we want to have in the memory of the MATLAB program. So now we have the variables in the memory that we want, and we can set about to plot those. So there's a very simple set of plot commands that are very handy for us. We can literally issue a command that says plot, and then in round or regular parentheses we can put the value p, and that's the value of the vector that we've loaded up. So that should plot those 9 values that we've already seen. And we hit return now, and we'll see that in a sec a figure window will pop up. We may have to go find that window. It may be hiding somewhere. Oh, sure enough, it's hiding back there. So here's our figure 1 window, and these are the values that we just entered as a very coarse approximation to that nice smooth curve we had in the graph. But now we see it's there. Now the problem is that these numbers in the x-axis are not the time units that we wanted to have. This just goes from 1 to 9. It's really just, turns out, what's called an index of the value within that matrix. So let's get rid of that. We don't need that anymore, because what we really want to do is use that time base that we had in order to plot the value of, in this case, if you hover over it a little bit, you see there's an x and a y. And so we're going to put t as our time base as x, and then we're going to put p, our vector, as y, and then execute that command. And there we see our figure window, and same shape as before, same values in the y-axis, but now the x-axis actually includes the time values that we expect to have. And so we've created a very simple plot. You can see how easy it is to make those plots. Now there are some straightforward commands that are kind of handy to use for plotting, because what's a graph without a label? So we can have commands like xlabel, and then we put a string inside that label, and you see now these strings have simple single sort of apostrophes to identify the text that we're going to put in there. So we're going to make that a label with x on it and finish that command. So that's the command that's there, and if we hit that command, then it does something. And if we go find our figure again, let's move things around. Oh, there's our figure again, and we look here, then we have time showing on the x-axis. Okay, so now let's get rid of that figure again, and we'll say y label, and we'll do the same thing, only this time, oops, we'll put the right kind of apostrophe. Now we'll put in the value of pressure. So pressure, that's what we've measured here, and we're going to have it in units of millimeters of mercury. So that's our string, and then we hit semicolon, and oh, and it's undefined labels. So you see, this is typical of the kind of mistakes we can make if we're not careful.
But it's smart enough to even suggest a correction. It says, did you mean Y label? Only this time spelled properly. No, we do. That's exactly what we mean. So now we hit return, and now we're good. But now we only have a label and no contents anymore. And that's because I got rid of the figure, and it erased that figure and all the contents of that figure. So we have to be a little careful when we erase things and how we do things. But I can recreate this very easily. If I press the up arrow, I can see all the commands that I've executed, and I can go back to the plot command, and it's made my plot for me. And then I can go back to my label command, and I can say, here's my X label. Oh no, this is the X label. I can make the X label, and then I can do the Y label, the correct one, and then I can go find my figure again over here. So here's my figure. Oops, where did it go? This happens quite a bit. It sort of disappears when you're not careful. So I'll move it off the window, move this window up. You can move your windows around as you need to. They're pretty flexible. So now we have a window with the Y label and an X label just as we defined it, and a plot. And you see the axes are numbered automatically. So the axes values go from 80 to 120 because that's the range of data we gave it. And they go from 0 to 0.8, which is the range of data we gave it for the time base. And that's how we create a simple plot in MATLAB.